Hi. Do numbers make you hard? Does probability, statistics, and data ignite a fire in your loins? If so, you've come to the right place. Welcome back to Data Diving Dude. And today's episode is inspired by my friend's Discord status, which is who wants to play Russian roulette? I'll go first. And what I was thinking was, what would be the best place to go in Russian roulette? So Russian roulette is you take a gun, you put one bullet in a chamber, you spin the chamber, you point the gun at your head, and you pull the trigger. And you take turns until the bullet fires and kills somebody. Fun stuff. Now, for this I assume that we did a standard 6-shooter revolver. And there are two scenarios. The first scenario you're going to look at is you put the bullet in one of the 6 holes, you spin the chamber, and you pull the trigger, and if it misses, you just hand the gun to the person who pulls the trigger. You don't respin the chamber every time. Essentially, you're not shuffling it. So if you survive the first shot, there's now a 1 in 5 chance you're going to die on the second shot because there's 5 slots left we haven't checked, basically. So we're going to talk about some terms, and we're going to, real quick, and we're going to talk about how this plays out. So, right here, column A is the number shot it takes for the bullet to come out. The number of shots in the game, I suppose. And then B is the outcome. So the first shot, if the bullet fires in the first shot, player 1 is dead. And if the bullet comes out in the second shot, player 2 is dead. Okay. Now, PMF stands for probability mass function. This basically means that this 16.67% chance, which is 1/6, is the chance of this outcome happening in column B. You could think of this way. You're rolling a 6-sided dice. Whichever number the dice shows is the number of shots it's going to take for the bullet to come out. In fact, there's no advantage to going first or going second from a probability statistical standpoint in this game. It's literally just a dice roll. If it rolls an odd number, player 1 is dead, and if it rolls an even number, player 2 is dead. So this is a pretty simple example, but we're going to use it to talk about some other things and go into what happens if we spin the chamber and essentially shuffle where the bullet could be in the next scenario we're going to look at. But first, we're going to look at these other two columns. So PMF, this is the probability of this outcome happening in row 5. CDF stands for cumulative distribution function, which basically means it's the added probabilities of all the outcomes before it and including it. So right here in the cell D6 here, 33%, which means there's a 1/3 chance that the bullet comes out on shot 2 or shot 1. And here, an 83% chance that the bullet comes out on shot 5, shot 4, shot 3, shot 2, shot 1. Survival is 100% minus the CDF, so which basically means that it's the percent chance that it takes more shots than that outcome for the bullet to come out. So here, there's a 33% chance that the bullet comes out on shot 5 or shot 6. So the CDF includes the current row and the survival function doesn't. So that's basically a quick overview of these kinds of things we're going to look at. And we're going to look at now what happens if you spin the chamber every time. Is there an advantage to going first, advantage to going second? Well, they're doing a bunch of math here. I plotted the first 30 outcomes. This is what's called a geometric distribution. And a geometric distribution means that you keep doing trials until an outcome is reached, like flipping a coin until you get heads, or by shooting a gun until a bullet comes out. So each time there's less and less likelihood of it coming. So for example, we went all the way down to 30. It technically could go ad infinitum. But there's only a 0.08% chance, which means 8 over 10,000, only 8 out of every 10,000 outcomes will take 30 shots for the bullet to come out, or 30 trigger squeezes. So as you can see, the probability goes down with each outcome. And this is part of the reason why it's better to go second here in this situation if you want to live. Because you'll notice that the PMFs under player 1 are always higher than the PMFs under player 2. And in fact, it's about 55 to 45%. There's a little bit left off because obviously this could go ad infinitum. But you definitely want to go second here if you're spinning the chamber every time. So the expected number of shots is 6 because there's 6 bullets in the chamber. It's a 1/6 chance, so you expect 6 shots. The standard deviation is 5.47, which basically means that standard deviation is hard to explain, but basically means that the average distance a point is from the mean is standard deviation. So your average outcome is going to be between 1 and 11 shots. That's oversimplifying it, but that's basically what standard deviation is, like super oversimplified. I don't want to get too technical here. So I plotted so we have the columns again. So PMF, the probability of each individual outcome occurs. So for here, there's a 3% chance, almost a 4% chance, that it will take, that the bullet will come out on shot number 9, killing player 1. There's an 80% chance that the bullet will come out in the first 9 shots. And there is almost a 20% chance that the bullet will take more than 9 shots. Remember, CDF includes the row and survival function doesn't. So CDF and survival aren't really that important as to and try not to get survival function. It's just a physical term with surviving the bullet here, because it's kind of it's two different things. Survival function is a specific statistical term, and versus surviving a Russian roulette thing. So we have so here we have the probability mass function, also known as column C, mapped out here, and you can see the lower shots have higher probabilities, and as more and more misses rack up, you have less and less probability of it happening. So this is a very simple example, but I hope it teaches you a little bit about probabilities and combinatorics and thinking about outcomes, and we will see you on the next time. Please feel free to comment about how shit this video is below, and how many times I said if you can count that, go for it. Peace.